A single failure cannot result in the loss of normal law. However, multiple failures of flight control, hydraulic, or electrical systems may result in a degradation of the flight control law. The level of degradation will depend on the severity of the failures. Degradation of the flight control laws is sometimes referred to as reconfiguration. We will study these degraded laws in order of increasing severity. In alternate law, ground and flare mode are as in normal law. Flight mode, pitch control. Load factor demand as in normal law. Roll control, conventional. Surface deflection is proportional to side stick deflection. Roll sensitivity is proportional to airspeed. Feels more sensitive. Yaw control. Damping available with limited authority. Degradation to alternate law is indicated by the ECAM caution. Flight control, alternate law. Protection lost. You will see this caution in detail in the abnormal operation module. Under alternate law, most protections are lost. Some are replaced by stabilities. We will continue by studying the loss of protections. Pitch attitude protection is lost, and the flight control computers will not limit the nose up or nose down pitch attitude. On the PFD, the green dashes which mark the protection limits in normal law are replaced by amber crosses. Bank angle protection is lost. On the PFD, the green dashes are replaced by amber crosses.
The load factor protection is similar to normal law.
In alternate law, the high angle of attack protection is replaced by a low speed stability. V alpha prot and V alpha max are replaced by a stall warning speed, VSW, indicated by a red and black barber pole. As speed approaches VSW, a gentle progressive nose-down pitch input is introduced to lower the nose and prevent further speed loss. The pitch input can be overridden by pilot input on the side stick. At VSW, an aural stall warning is triggered. The aircraft will stall if the warning is ignored. Alpha floor protection is inoperative in alternate law. In alternate law, high-speed stability replaces high-speed protection. The green dashes are replaced by amber dashes on the speed scale. Above VMO or MMO, a nose-up input is introduced to raise the nose and prevent further speed increase. This pitch tendency can be overridden by the pilots. As in normal law, if VMO-MMO is exceeded, the overspeed warning is triggered.
Note that according to the failures, an alternate law with bank angle protection and high-speed stability can exist. In this case, the ECAM message shows only flight control alternate law. However, all protection marks on the PFD are amber for simplicity, although some of them still exist.
Direct law is the lowest level of computer flight control. Pilot inputs are now sent to the control surfaces unmodified. Because of the large number of failures required to degrade to direct law, it is unlikely to occur during normal flight. In direct law, you will get an ECAM warning as shown, and additional messages on the PFD. We will study them later on. Direct law, as the name implies, gives a direct relationship between side stick movement and the deflections of all surfaces. In effect, the A340 behaves like a conventional aircraft, and control sensitivity will depend on airspeed. In direct law, there are no protections available, although stall and overspeed warnings will sound at the appropriate speeds. Auto trim is not available. The crew must trim the aircraft manually. Use manual pitch trim is indicated on the PFD. Auto turn coordination and Dutch roll damping are also lost. All yaw control in direct law is through the rudder pedals. In the worst cases of failure, such as complete loss of flight control computer power supply, the aircraft will revert to mechanical backup mode. In this mode, the only method of pitch control is manual adjustment of the THS using the pitch trim wheel, provided either blue or yellow hydraulic system is available. Manual pitch trim only is indicated on the PFD. Lateral control is achieved in this mode using the rudder pedals and their mechanical linkage to the rudder, provided at least one hydraulic system is available. In most cases, e.g. by resetting the flight control computer, you will be able to recover from mechanical backup to either alternate or direct law, depending on the type of failure. We will now see a brief summary of the different laws and their associated protections. In normal law, all the protections are available. In alternate law, the pitch attitude protection and the bank angle protection are lost. Maneuver protection is kept. High and low speed stabilities are introduced. In alternate law, without reduced protections, the high speed and the low speed stabilities are also lost. Only the maneuver protection remains. In direct law, all the protections are lost and the aircraft handles as a conventional aircraft. In mechanical backup, no more flight envelope protection is left. The pitch control is performed via the pitch trim wheel and the lateral control through the rudder pedals, thanks to their mechanical linkages, provided the appropriate hydraulic systems are available. You have seen all the different laws and protections. Maybe you wonder how to recover if extreme conditions cause the aircraft to leave the protected envelope, e.g., you've been flipped over by a very severe turbulence. Here is the answer. If the limits of normal laws are exceeded, abnormal attitude laws become active. This is a safety feature to ensure that the flight control computers will never prevent the pilots recovering from an abnormal in-flight attitude. The flight control laws operate in alternate law without protections in pitch, except for load factor protection, and without auto trim. In roll, direct law is provided, with yaw in alternate. After recovery, controls remain in alternate law for pitch and yaw, and direct law in roll. After all these emotions, you will now see the normal operation modules.